Okay, now we're going to solve a literal equation. If you remember from class, a literal equation is an equation with all variables. Like we have here. We have y equals ax squared plus bx plus c. There are nothing but variables, so this is a literal equation. Now, in our directions, we have been asked to solve for b. I highly suggest that when you're solving a literal equation, you highlight the letter you want to solve for. Here we want to solve for b. Now, the keys to success when solving a literal equation. Number one, you want to get the term with the variable that you want, a term with the wanted variable, isolated. Remember, isolated means by itself. So we want the term with the wanted variable isolated first. Then we're going to get that variable alone. That's the second thing we're going to do. So, looking at our problem, we have y equals ax squared plus bx plus c. Our variable is here on the right-hand side, so we're going to look at just the right-hand side. If you notice, there are three terms. We have the ax squared, we have the bx, and we have the c. So in order to get that variable term isolated, we need to move the ax squared to the other side, and we need to move the c to the other side. And we're going to take care of those one at a time. So let's move the ax squared first. Ax squared is positive. Remember, there's an imaginary plus sign in front of the a. So the opposite of positive ax squared is negative ax squared. So we're going to subtract ax squared from the left-hand side. Sorry, the right-hand side. When we do that, the ax squared term goes away on the right. But remember, when you solve, what you do to one side of the equation, you have to do to the other. So we're going to subtract ax squared from the left-hand side also. So subtracting ax squared from both sides, we are going to notice that on the left-hand side, we have y minus ax squared. Those are not like terms, so we're just going to write y minus ax squared. On the right-hand side, we still have the bx plus c that we haven't touched yet, so bx plus c. Now, once again, I'm solving for b, so I want to make sure he's highlighted. That way I keep track of who I'm trying to solve for. Okay, we still are on step one right here. The term with wanted variable needs to be isolated. So if I look on the right-hand side, my variable's b, it's with the x. That is not isolated because there's a plus c on the side. We already said earlier that plus c we need to fix. We got to move that c to the other side. So the inverse of plus c is minus c. We're going to minus c from the right, and what we do to one side we have to do to the other. So we're going to minus c from the left. Now when we do this, we're going to notice that on the right-hand side, plus c minus c, that goes away. So on that right-hand side, we're lucky. We're left with only bx. On the left-hand side, we have a y, we have an ax squared, and we have a c. None of these look the same to me, so we have no like terms. So on the left-hand side, we have y minus ax squared minus c. And now we're happy. Stage one is done. The term with the wanted variable has been isolated. So once again, to keep track of who I'm solving for, I'm going to highlight that b right there. I want to solve for b and get b all by itself. When I do that, I got to look at how it's joined with that x. There is an imaginary multiplication sign joining this b and x together. So how do you undo multiplication? Well, with division. So we're going to divide the right-hand side by x. And when we do, x divided by x is 1, so that goes away. And remember, what we do to one side of the equal sign, we have to do to the other. So we're going to divide that left-hand side by x also. This has now, for the left-hand side, y minus ax squared minus c, all divided by x, equal to just b on the right-hand side. And now we have solved for b in our literal equation.